Let's begin with computer networks. So computer networks we can learn in two ways. One is top to bottom, second one bottom to top. But whatever the way you learn generally, so what happens is because it's a huge topic, then there will be lot of issues and lot of devices, lot of protocols, everything. So whenever you try to understand everything at a time, you will mess up everything and you don't understand anything. That's why what we do is, since this topic itself or this subject itself is very huge, then rather than learning it in a textbook model, what we do is we go with a simpler model. That is, first of all, focus on, that means make your computer network subject very simple. That means we focus on one basic problem. Okay, example, generally it's a computer networks problem, correct? That means you have thousands of computers, they are connected through various networks and all. We should understand various protocols, various devices involved in it, various mediums where data can be transferred, right? So many things. So there are thousands of things to be learned, but if you try to learn everything one by one, you can't imagine them. Like example, if you learn bridge without its need, if you don't understand what is the need of it, then you can't understand why we are learning bridge. And if I teach you what is hub without knowing the reason for that, then it will be useless and you don't remember it and the subject will become dry. So to avoid that, what I'm going to do is, first of all, I will teach you the basic building blocks. That each each building block is nothing but which is going to construct your computer networks understanding. Example, let's say you are building very big apartment with hundreds of floors. Then don't try to learn how to build 100 floor apartment at a time. Learn first of all how to construct a small building, then we can extend it later. So always while extending, you will have a confidence that already you know how to construct a small building. Then using that small buildings, we can make it to 100, correct? In the same way, we learn computer networks. So for that, what I do is I start with a basic building block, how to connect to computers. You learn it, and what are the protocols required, what is protocol, and how to send the message from one computer to another computer. If you learn it and if you understand the problems, that's it. Remaining computer networks is nothing but extending it, correct? If you have hundreds of computers which are connected, then how to send the messages? If you know how to send a message from a computer A to a computer B, in the same way we can do it, right? Maybe some extra things we should do. That's why always my suggestion, first of all, forget about all your real world computer networks first. First of all, learn a small problem. So there is no world for you. In our world, we have only two computers first. So between these two computers, if you are sending the message, what are the things you need? Right? We learn them. Let's begin with that concept. I have two computers and I'm going to send some message. So whenever I say I'm sending message, we need medium, right? That's quite obvious. Example, two people are communicating. Raju and Rani are exchanging the messages in the real world. So definitely they need a medium, right? Through air, the voice will go, correct? So here, in the same way, when you have two computers, how can they communicate? What is a medium, right? So this physical medium is what? Is it a cable? Yes, there are so many ways again. So one is, a copper cable, second one optical fiber cable, otherwise, air. Through air, using the Wi-Fi signals or whatever the signals, we can still send the data. That's why let's abstract it, hide that kind of details first. So simply we say medium, whether it is Wi-Fi or anything doesn't matter. Let's say we assume that, so this medium is going to transfer our desired data first. Okay, then how many components you will see in this entire communication system? So you will see one sender in our model, right? So sender S, receiver R, and anything else, this one physical component you are seeing, medium, and message is very important, right? That is what you are going to communicate. So fifth one is protocol. So what is protocol? Without protocol, can I do that? So what happens without protocol? We'll see. Let's say the system is, let's say Raju. So when we take people, generally it will be easy for us to understand the things. That's why I use these kind of, imaginations. Like generally most of the times I take human beings. Let's say Raju wants to send message to Rani, then why protocol is required? Protocol is nothing but set of rules. Why that set of rules are required, I will tell you. So example, let's say without rules, if they don't have any understanding between them, then if Raju sends letter to Rani, then what happens? She might not be able to receive it, right? She says, I don't want your message. One thing. Second one, if Raju sends message in English, let's say, but Rani doesn't understand English, she can only understand Hindi, that's it. Then how can she read? Again, there should be a common understanding. So finally, whenever sender sends data, then there should be some particular rules for how to understand the data, and when to react to the data. That means when to read the data, everything, correct? So availability also important. Raju and Rani should be available whenever you are sending the message, correct? At least while Raju sending message, Raju will be obviously available. Then Raju, when he is sending, Rani should be able to read it. For that, first of all, she should be available, correct? So finally, all these things are common understanding. Raju and Rani should come to one common understanding. That is nothing but a protocol. So example, one typical protocol is like this. So Raju and Rani are agreeing like this. Rani says, see, I have a post box. So whenever you send a mail, simply, somehow you ensure that it comes here. That's it. I will take care of remaining thing. And one more thing, by the way, you write letter in English. I understand it. Only two things. So if that kind of common understanding, if they have, there are two rules, correct? So if they follow these two rules, automatically there will be happy communication, correct? So that's why protocol is important. So protocol is the fifth component in this communication system. So I can say protocol is nothing but simple set of rules which are going to govern your communication, right? So this is about a simple model. Now we'll see the properties of this model. What are you going to expect from this model? Like, what do you want from this communication system? So one is delivery. That means my message should be delivered, correct? So Raju is expecting, otherwise anyone is expecting in this communication system is delivery, correct? Second one, anything else? Just delivery. So one more thing is, security, I can say, correct? That means your message should be securely sent to Rani, correct? I say security is also important, delivery is important, reliability is also important. There are so many characteristics, otherwise properties of your communication system. I want a reliable communication system, right? Secured communication system, reliable. What is the meaning of reliable communication system? In reliable communication system, I should not lose my data. That's it. That means errors should not be there. Example, if I send some letter to Rani, what should not happen is, because of this communication medium, so some of the letter has been teared. Otherwise, some of the characters are, otherwise some of the information is lost. Something happened because of heavy rains or whatever it is, so your message should not be corrupted. So we say that such kind of communication system is reliable and secured. That means while Raju's letter is going through this communication medium, what happened? There is one more person called Mr. Rakesh. Rakesh tapped that message. That means, in between he took that message and he, ran away. Imagine the situation. Yes, it happens. Then that is security problem. We should take care of that. And one more thing, timeliness. Example, let's say Rani is waiting for that letter, and only she can wait up to a lifetime. After that she cannot wait. It is a simple model. So Rani is able to read that message only until she is alive, correct? That's why Raju should send it in a timely way, at least within 60, otherwise 70 years, that message should reach, correct? So similarly, sometimes there may be urgent messages, like, so Raju should send that message. Example, Rani is leaving to other place. She is relocating. When she is relocating, then only she wants to stay here for 1 hour. Then Rani is expecting the letter within 1 hour. So finally, one more characteristic is timeliness, right? So timeliness. One more thing I can say, jitter. So jitter and timeliness are related. I will tell you what is jitter. So sometimes, especially audio data and video data should have zero jitter. I will tell you what is jitter. Example, you are sending some video message, otherwise whatever it is, some video through some communication channel, otherwise communication system, or otherwise medium. So this is the receiver. So receiver is, let's say this movie is going to be watched by some candidate called Rani. Okay, so Rani is going to watch that movie. What happened? So watching movie is nothing but these movie pieces. I can say at this moment, let's say your movie is divided into some images. Watching the movie is nothing but watching that images some in a particular way. Okay, so let's say image number 1 she is going to watch. after that image number 2, then image number 3. But she can happily watch that movie if I1, I2, I3 comes in a particular interval. Example, I1 comes after 30 millisecond, but I2 comes after 40 millisecond, and I3 comes after 70 millisecond. In that way, if there is a variation in the arrival of the packets, what can happen is, so here Rani feels some jitteriness, that is called jitteriness. So there will be some uneven delay. Whenever there is uneven delay, then you don't feel that you are watching the movie continuously. Continuity will be missed. That's why jitterness is important generally. So I mean, jitterness should be 0. If jitterness is very high, it's nothing but variation of the arrival of the packets. So the variation of the arrival of the packet should be 0. That means everything should come in a periodical interval. That means a particular interval. Then it will be very good. Correct. So these are the characteristics, otherwise properties, I can say, every communication system should possess, right? Now we'll see one more important parameter here. So this channel. So communication medium, otherwise channel. In this channel, the communication can be in 3 ways. The mode of communication we say. One is simplex. We say that a channel is simplex, otherwise a channel is half duplex. Third one, a channel or a communication medium is full duplex. What does it mean? We will see one by one. Whenever I say communication medium is simplex, otherwise channel is simplex, that means the communication is only one way, strictly one way, other way is not allowed. Example of simplex is, in real world, is TV versus audience. So some audience is watching TV, okay, then it's a one-way communication. TV sends the message and this audience receive it, correct? So now, but audience cannot send the information. That means, so when, see here, audience is watching TV, but TV is not watching audience, correct? So if he shouts suddenly that, stop, it cannot stop, correct? Of course, forget about remote. So if you see TV versus remote, that's a different story. I'm talking about, let's say, audience without remote and TV. Okay, so TV sends some information and he enjoys it, correct? But one example, let's say if this fellow dances, then the TV cannot understand and it cannot watch, correct? So that's why this kind of communication is simplex. Yes, there are some channels in our computer networks. They only allow one-way communication. Maybe that's a property of medium sometimes, and you need it sometimes, right? So we'll see whenever time comes. Now we'll see just what is the meaning of each mode of communication first of all, and we use them whenever we want. Half duplex communication. So in half duplex communication, so let's say this is something sender, otherwise let's take 2 computers or any computing devices or communicating devices, and this is the medium. Then whenever I say this medium is half duplex, then either A can send data to B at a time, otherwise B can send data to A, but not both at a time. That means your communication is only one way. The difference between simplex and half duplex, so it is always only one way, but here you can change the way. That means for some time A to B, after some time B to A is possible, but not both at a time. Such kind of communication medium is called half duplex medium. Third mode of communication is full duplex, where so A can send the data to B and B can send the data to A at a time. That means it's a multi-directional. So this is called full duplex communication. So it depends on the channel's properties, right? Some channels cannot allow two-way communication. So some channels allow two-way communication. It depends on the channel property, I can say. And sometimes it depends on your requirement. Though your channel is capable of allowing and sending the messages from A to B, B to A, but if you don't want it, maybe other reasons, then still we say that it's only half duplex, correct? So finally, these are the 3 things. Let's summarize. Simplex, only one-way communication forever. Half duplex, so it will be like context switch, other switching. That means A sends half an hour to B, it is possible, but at that time B cannot send to A. Then after half an hour B can send to A. So both ways are possible, but one way at a time. So that is half duplex. In full duplex, A and B are parallelly sending the information to each other. So that is full duplex. So there can be 3 modes of channels. Understand? Now what we do is we take 2 computers now. We just learned some of the terminology, right? And we take 2 computers and we try to send the message from one computer to another computer. In this process, what are the things we require, and we learn them, right? So slowly you are understanding my idea, right? First of all, I start with some basic computers or two computing elements, and I will try to connect them, and I will teach you what are the essential things you need to have effective communication. Then we extend it, right? So we'll do that. Now take these two computers, one is sender and one is receiver. Then I'm going to connect them, and I'm going to send one message from sender to receiver. Then what are the issues we are going to have, we will see. First of all, to send some message to receiver, there should be a connectivity, correct? So I'm talking about a simple connectivity. So where I just connect these two computers using some cable, right? So but generally every computer will have a network interface card. Let me show. Actually, it will be inside. That means it will be somewhere here. It depends on the computer and laptop, whatever. So there will be a card called network interface card. Similarly, this computer also having network interface card. So each network interface card will have some software and some hardware. So that software and hardware is going to decide, otherwise that is going to direct the flow. That means that will know everything about sending the data from sender to receiver. That's why I am assuming that at this moment we have, let's say, NIC card for every computer. That is for sure. So every computer which is capable of having having connectivity. That means if your computer is ready for connecting it to other computer, definitely it will have NIC card. Otherwise you can't connect it to compute internet, first of all. So network interface card, it will have some ports. So we'll assume that, let's say, there is one port now. Usually it will be only one port, sometimes it will be two, doesn't matter for us. We assume that, let's say, our NIC card has one port. Here there is another port here in receiver. Then through some cable we are going to connect like this. Okay. Now, of course, this NIC will have all the essential software. Because of that, automatically you can send the message from here to here. But we learn now. So in this NIC cards, what kind of software will be written and what are the functionalities of that NIC card software? To understand that, forget about the role of NIC first. Now assume that, let's say, you have two computers and so to one cable and you connected them. Okay. Now think about the software inside NIC that we are going to discuss. So first of all, before going to that software part, this is called port. We are now going to use a word called port. Port, otherwise interface. So port or interface is nothing but this is a point which is going to help you to have a communication. That means through this point we are going to connect this computer to another computer, otherwise any other thing. Okay. So that is called port. Port is a point. Now we have, let's say, two ports. We connected them. Now the question number one, you tell me, let's say, whenever you send the message, let's say your NIC card is capable of sending a message from here to here. First of all, let me stop here and I will tell you how NIC card will do it. So generally, so this is a cable, right? So this cable is a passive element, otherwise passive, I can say, object. So this cable cannot have intelligence, otherwise any software. Now this cable is going to carry your message, right? So finally your computer A, let's say this is A, this is B, or anything, maybe laptop, doesn't matter. Let's say your computer or computing element is having some message, let's call it M. So this message, whenever you send, what happens? What your NIC card will do, first of all, I will tell you. So this, because your NIC card is connected, that port is connected to another NIC card. Whenever you give that message to this NIC card somehow through software, then this NIC card is going to push that to this computer. Because it is our simpler model, question number one, this will not arise. That is, sir, how this NIC card will know that message to be sent to this computer? In our basic model at this moment, we assume that, let's say, these two computers are connected and your NIC card will know because this cable, because in this port you have inserted some cable, and whenever you give the message, that NIC card will automatically push that message through the cable, and especially your message will be converted to signal. What kind of signal doesn't matter for us. So that's why what we do is, so first of all, let's say in the high level, your computer has some data message. If you open that message and if you see, it will be zeros and ones. That is our understanding. But we know that zeros and ones cannot be directly sent to sent through communication channel, there should be a conversion. So let me call this as data element. So this is your data, right? We say data element. Each and everything is a data element. Now these data elements are converted to signal elements. That means 0 will be converted to some signal, 1 will be converted to some signal, whatever it is, doesn't matter. We don't focus on that, right? So somehow finally every 0 and 1 will be converted to some voltage signals. That is enough for us, okay? Otherwise signals. So these signals are called signal elements. So finally every data element will be converted to signal element, and after that it will be put on this cable by your NIC card. Automatically, because of your physical properties of the signals, then it will propagate. So it will propagate like this. Example, whenever you keep 0 in the high level, that is our imagination, but corresponding voltage signal will be transferred like this. It will go like this and it will reach here. And there should be corresponding software which should wait for the signal, and whenever that signal comes, that software should be invoked, and that software should take that signal and it should convert that signal element to again digital element. So this entire thing will happen because of software. That's why this NIC card will have software, this NIC card will have software. So that software is going to control, otherwise is going to govern this communication. Now responsibility of your NIC cards is nothing but whenever a high level software gives some message to this NIC card, and if they ask please push it to another computer, then that NIC card is going to push that signal elements, or otherwise first of all the digital elements will be converted to signal elements. After that they will be pushed to another through cable, that's it. Because this cable is connected to this end, it will reach here, then there will be high level software, maybe it is waiting. If that software is waiting for the signals, then it will receive. Okay, so that's why finally I can say that there is high level software. We should understand that apart from this NIC cards, there is a high level software that is nothing but, let's say, for us application software. So there is an application program AP1, there is another application program AP2. Actually they want to exchange the message. For that already they have agreement. That means they want to send one message from A, wants to send one message from here to here. Then at that time that data will be given to NIC card, and that NIC card is going to send that data through this cable. Now at this moment we abstract it, don't worry about it. If I start teaching what is application program, how it does, that is not appropriate now, correct? So that's why I don't discuss now. Whenever time comes, we'll discuss. At this moment we focus on a simple problem. Someone gave some message to your NIC card, and that is going to be transferred to another port through this cable. That means another NIC card. That is our scope now. So second thing we should see, don't worry about address. That means how this NIC card knows the address of this one? Nothing, because our model is what? Recall. There are two computers, you connected them. Now someone gave some information to NIC card, message, and that message is going to be sent to your another computer. For that, simply your NIC card will put that message in this port automatically, because it's a signal, it will be transferred. That is what our understanding. Understand? Now if there are multiple computers, then question comes, through which port we have to send the message. Do we have that question now? No. Then why to bother? Understand? That's why when there are two computers, the communication is very simple. Whatever the data comes from high level, so that will be directly put here in this port. We can imagine it as one end. Whenever the signals will if you put here, automatically this will be transferred here because of the signal properties. That is called propagation, right? Now one more thing, sir, what if whatever the signal I send, if it is corrupted? That is one thing we should talk about. That means in high level we talk from now onwards, we don't bother about signals, because whenever you have a message, automatically that will be converted to signals, and that signal will be propagated to send receiver, and receiver receives the signal, and again that will be converted to the same message where you have sent, correct? So this M and this M are same. Now we do one thing, from now onwards we don't bother how the signals, how messages are converted to signals, and how the signals will be converted back to message. There will be a converter, encoder and decoder. so we don't bother about it, right? So they are again part of NIC card. That's it. Now we bother about remaining things. That is one thing. What if my message, if I send my message M, if I lose it in this communication medium? It happens because in reality, whenever you have a cable, then that is a physical thing, right? So in physical world, when you are communicating, anything can happen. One thing, so there may be a cut in this cable, then nothing will be received here. Second thing, there may be some disturbance, I can say. That means this cable is going through some other medium where there is one more cable on this cable. Because of some interference, then you might lose some of the signals. That means positive voltage may become negative voltage or zero voltage, and zero voltage may become negative voltage or anything. That means these computers are assuming that signals are, one is 5 volts, second one 0 volts. 0 volts represents 0, 5 volts represents 1. What can happen is, why in this communication medium, because of some inference, so this 5 volts might become 0 volts, it's possible. Then your 1 will become 0. That's why, rather than worrying about that level, in the high level I say that sometimes because of your physical medium, my 1 may become 0. That means your message may be corrupted at some point. Then how to handle it? It is one important thing, right? So whatever the question, this is one general problem any computer network will have, correct? So that's why we have to focus on that. That is called error control. How to control the errors? That is one responsibility we have whenever we have two computers and which are connected, right? Second thing, what is the other thing we have is, example, let's say this sender is nothing but, from now onwards imagine like this, there are two components in my computer. So this is my computer A. So in my computer A, there is a high level user or high level software. Let's say that is application, we say. Okay, this application is going to decide what to communicate. So it is going to provide us message. Now we have second level, that is nothing but this NIC card. We, from now onwards, we say usually that is called data link layer. Sir, what is layer? I will tell you. So there are two functionalities, if you clearly understand. One is creating the message and communicating through another computer, correct? So creating the message and dividing that into proper parts and worrying about the syntax, everything is one thing. The second thing is how to send that message effectively to other computer, right? So that's why let me divide my software into two parts. One part of software will create the messages. Second part of the software will send the message to another computer, right? So here this NIC card is going to have this data, also known as data link layer. So I'm slowly introducing. That's why don't get surprised if you see a new word. You are now in learning mode, right? Whenever I say something, you just blindly follow. Understand? Because you are now learning. I'm defining so many things. So this is data link layer. It's a just name. It is some set of software. This is some set of software. Now this data link layer is a collection of softwares which is going to worry about sending your message which is given by high level software to another machine which is connected to it, correct? So we will see what are the things we have to do. We focus on now how this NIC card, otherwise data link layer, is going to achieve it. So we don't worry about this application layer, how application layer is going to create a message, what is the syntax of it, we will see that later. Now we are focusing on data link layer. So before concluding here something, I would like to add one more thing. Finally, I can show one more layer, that is physical layer, which we don't generally discuss. So we will, let's separate physical layer, data link layer. I'm just introducing. Third one, let's say application layer. This is just our imaginations. It is not a standard one. Okay, so just imagine. This is not real one actually. We are going to have correct one. First of all, for our problem, there will be three layers. Application layer is going to give us message. Otherwise, I can say high level layer. Second one, that message will be taken by your data link layer or NIC card. Okay, that data link layer is going to send that message to another computer. But we need one more layer generally. So why we write software in these many modules? Because this physical layer is nothing but which worries about only this physical medium. Like example, let's say, what are the different physical mediums you have? One is cable, copper cable, correct? Otherwise optical fiber system. So your cable may be optical fiber cable, otherwise copper cable, otherwise maybe that radio frequency signals, otherwise I can say air. Through air you are sending. So these are the various mediums you have. Then when there are multiple mediums, then how to send the message? That means how to convert this, I can say your data elements to, already I told you what is data element. You have data element, how to convert this data element to the right signals. That means if it is a copper cable, then we provide, otherwise we create some kind of signals. If it is air, maybe then you go with radio signals, correct? If it is optical fiber, then you might create different kinds of signals. So what kind of signals are good for a particular medium? Second thing, how to send them, everything is the responsibility of physical layer. Let me divide that into three parts so that our I can say about modularity, right? When you write, I mean when you divide the things into some parts, then it will be easy for us to understand. That's why, so whatever the functionality you need finally to send one message from one computer to another computer, I am simply dividing into three parts. So this physical layer is nothing but you have data finally. How to send this data to another computer, that's it, in this physical medium. The physical layer's duty is only understanding this physical medium. What kind of physical medium we have, how to send the data. Okay, what kind of signals to be used. That's it. We don't bother about physical layer much. Now we'll see data link layer. So what is data link layer is, of course sir, what is NIC card? It's a device. So this NIC card is going to have software related to data link layer and software related to physical layer. Okay, don't worry. Now in that NIC card you will have software related to data link layer. What is the functionality of data link layer we are studying? So this is, now we are here now. This is very important for us. We don't study physical layer, but we just understand what physical layer does, what kind of software this physical layer contains. Layer means module, some set of softwares. So this physical layer software contains information, otherwise protocols, which are used to convert your data elements to physical signals, maybe radio signals or otherwise any other signals. Maybe there are so many ways, like analog signals. It depends on your medium. So it doesn't matter for us, but finally how to create them into signals and how to send them effectively from here to here, that's it. That will be taken care by your physical layer and we don't worry much about this. But what are the remaining things? There are a lot of remaining stuff we will see one by one. Who will create the message? First of all, application layer. But how to create and what kind of things to be taken care in application level, we don't bother at this moment. Now I want to focus on this remaining part. What is that? I don't want to worry about the physical medium. I don't want to worry about how to create the message. But in between there is something else that I am going to teach. So that is part of functionality of data link layer. We will see that. Now the responsibilities of data link layer. So you ask yourself, so why I am teaching in this way is so that you can understand. So whatever comes to your mind, just open it up. So automatically data link layer functionality will be calculated. First of all, error control, because we know that physical layer is not going to deal with error control. The job of physical layer is simply understanding the underlying communication system and sending the data, that's it. Okay, now data link layer is going to have responsibility of error control. What is error control? Example, let's say this is your communication medium. Let's say this is sender, this is receiver. Now finally your data is available. Let's call message. Okay, now you want to send this message from here to here, but in the next level, that means in your computer there is some extra software, that is physical layer software. You simply hand over that message to this physical layer software. Because of that software, okay, so most of the times we require very minimal software here in physical layer. Okay, because what is the job of that software? So otherwise we say protocols. What is the job of that protocols? The job of this physical layer protocols is nothing but simply converting that message to signals and simply sending up. You don't require really a well sophisticated software here. I can say that to do all this job we require hardware. So I can say that physical layer almost will have 95% of the time it will have hardware. All the job of physical layer will be done by hardware, some little bit software 5%. Okay, that also will be embedded in your hardware. Okay, so I can say that almost it's a hardware, I can say, physical layer. So now the question arises here. So your physical layer will take your message and it will send here. But what can happen is, because of the properties of your cable, so maybe inference, or so I will tell you, I told you. So because of your lines inference or any other problems, what can happen is your message might get corrupted. We imagine like this. See, your data is going like this, 0 0, your message is traveling like this, only one bit. Suddenly, because of inference here, this 0 might become 1. Then B will receive wrong information. But who should take care of that? Neither application generally. So data link layer is going to take care of that, because that is the response. I mean, such a way it is designed. Okay, it's one module. So data link layer should do something. So we are studying that. Sir, why data link layer should do that? Let's say other layer should do that. That is nothing but data link layer. So now, one more thing I have forgotten to tell you. Whenever we connect to, I can say, two ports like this, this is called, link. Just we use a word called link. Now that's why data link layer protocol is nothing but when there are two computers, there will be a link, and how to send message effectively from this point, one end of the link to another end. That's why that is called data link layer. So in this data link layer, we worry about how to send it effectively. Sir, what are the problems we face? Why didn't you directly give that to physical layer? Then first thing is errors, right? So because your cable might be having some problems, because of that your data may be corrupted. Then we should take care of it. How to take care of that thing? We will see error control. Second one, flow control. Let me write. So what is flow control? Now what is flow control is, take this example. Let's say this is sender A, this is receiver B. Now A is sending some message to B, but that message is very long. Otherwise we assume that, let's say there are 1000 messages which A wants to send to B. Then this receiver may not be always available, correct? This receiver might have other word, correct? If that is the case, that means if your receiver is not responding at this moment, then what happens? Then whatever the message comes here, then immediately if you don't take it, then someone should hold it, correct? Either this B should hold it, otherwise it will be discarded. Automatically you lose it, correct? If you don't want to lose, if you want to process it after some nanoseconds, then simply we should have buffer. That's why the mechanism will be generally maintaining a buffer. So whenever a message is sent by A, that will come and sit here. Then second message will sit here, third message will sit here. Whenever your receiver is ready, then he will process in this order. Maybe this is, I can say, queue, right? Queue model will work. Now see this. Example A is continuously sending. Then what happens after some time, because it's a finite buffer, right? So let's say buffer capacity only it can hold only 100 messages, but your sender is sending lot of messages, more than 100. Then we say that A is going to drown B. Otherwise A is going to flood B. So whenever A wants to, otherwise A is going to flood B, then what happens? Then some of the messages will be lost. To avoid that, there should be a communication between A comma B, right? And there should be agreement between them. That agreement will be generally, before sending the first message itself, A says that, my dear B, how much buffer you have? What is the size of the buffer? And what is your speed? Everything. So that is called a protocol. Finally, there will be a common agreement, and that is called a protocol, and A and B will follow that protocol. So what kind of, how to have this kind of protocol? What is the best protocol for this problem? Is nothing but flow control protocols. Finally, so that there should be a common agreement for various things. Your sender and receiver should agree on so many things, correct? They are all called protocols. If I divide that protocols into so many parts, some are called error control protocols. So error control protocols are going to control the error. Second one, flow control protocols are going to solve this problem. That means which will stop your sender flooding this B receiver, right? So this is flow control. Third one, see this situation. That is called framing. So why framing is one more important thing every sender should do, we will see. Example, you have a very long message of size 1 lakh bits. Okay. So that 1 lakh bits if you are sending to B. So the common agreement is Mr. B, I am sending 1 lakh bits. Then please wait for me. Until I send this 1 lakh bits, you have to keep quiet. Don't send anything because our medium is maybe half duplex. Let's imagine this is half duplex. If this is half duplex, only one person can send, correct? Then problem number 1. So is this medium is controlled by A. That means so for this much duration, example, to send 1 lakh bits, it takes 1 hour for computer A. Then up to that time your B should wait. Is it a fair thing? So it is not fair because of B is not able to send messages to A, right? That's why that is one thing. Second thing, error control problem. That means if there is an error in the line, of course, though you have error control mechanisms, what might happen, we'll see. That 1 lakh bits you sent in between, because of this cable problem or whatever, some of the bits got garbled or corrupted. Then what you do? One simple technique is resend. See now, in that 1 lakh bits, we don't know which bit got corrupted. Let's say receiver doesn't have any idea which bit got corrupted, but receiver knows that there is a mistake. Somehow it detected. We will see how to detect whether a message is correct or not. Okay, error control techniques will teach you. So at this moment, let's say through error control techniques, B understood that there is a problem in message. It should be resent. So simply B said, Mr. A, please resend it. Is it a fair thing? If the size of the message is 1 lakhs. That's why finally one more thing what we have to do is generally whenever high level software, which is nothing but for us application protocol, right? So this application layer, sorry. So this application layer, whenever it gives you message, if its size is very long, then we should divide that into some pieces. Then only our sending the data will be easy for us. Example, in the real life also, let's say you want to change your house, that means you are shifting your house. Okay, there are a lot of very big things like you have a cot, you have fridge, you have TV, everything. So that movers and packers people, what they do is they pack the objects into some fixed sizes, right? Example, you have very big object like a very big cot. What they do, they divide it into some parts, right? Top and bottom, that legs, everything they divide and they send. So it will be easy for good communication. In the same way, what we do is we divide our message which is given by your application level into some frames. So from now onwards, you remember in this data link level, that means we are solving the problems related to link. Why are we doing all these things? Error control, flow control and framing, to send a message from one computer to immediately next computer which is connected through some physical line, correct? Otherwise some link. So this is a link to link communication. Whenever you have a link to link communication, in that various problems you face, so we are going to solve them. So in that one thing is framing. So we divide the message into multiple parts, framing. So framing is done in this data link layer. Of course in other layers also, so this kind of division might possible, but in data link layer also it is possible. Now what are we going to do is we are going to study error control in detail and flow control in detail and framing in detail. Then if you learn all these things, then it is exactly equal to learning how to send a message effectively from one computer to another computer which is directly connected to it. Understand? Once you learn it, then we'll go to the other kind of communications. Okay, so we are going to do that. At this moment, let's stop it. So we just understand that these three things are required. Now I am going to tell you one more model, that is how to connect multiple computers. Just now you have seen how to connect two computers, correct? Now we'll see what if you have hundreds of computers, how you connect them and what are the problems we have to solve. We will see that also. Okay, now we'll see how to connect multiple computers. Example, you have a computer A and computer B, computer C. So how to connect them? We know how to connect two computers. Let's do that first. AB, there will be a NIC card, correct? In that NIC card there will be a port, correct? So this port, and this B is also having one NIC card, correct? Port. Connect them like this. So we know that we can connect like this. Now what about connecting B comma C? Simply connect like this, sir. There will be one more port here. So in C there will be one port, you connect them, right? Yes, fine. What about another computer? If you have another computer, how you connect them? So one thing is, for easy connections, take port of D, one port of D, and there will be one more port of C. Connect like this. So here you are using very less number of connections, correct? 1, 2, 3. So there are 3 links. But sir, how A can send message to C? So far we learned how to send a message from one computer to another computer. For that, essential thing is there should be a connection, physical connection, right? There should be a point to point link. This is called point to point link. From now onwards you remember, so this link is called point to point link. So it is especially dedicated between two computers. Now here there is no point to point link between A to D, correct? Otherwise direct link. There is no such link. Then how A can send a message to D? So we need to write extra software in your NIC card and such a way that this A should be able to send a message to D. For that, what are the things we need? Think about it. One thing. Now addresses comes into the picture. That means every computer should have physical address. Okay. So don't think about IP address. We don't require IP address. So we don't know at this moment. Let's say forget about IP address. We don't know what is IP address, but we need some address. So that is called physical address. I will tell you why it is called physical address. So this physical address, example, this physical, for simplicity we assume that it's a 3-bit address. So it is, let's say A means 100, B means 200, C means 300 physical address, D's physical address is 400. Now what we have to do is, whenever A wants to send a message to D, then in the packet or message or frame, from now onwards we say frame because we divided the message into frames, correct? Now in this message, in some fixed part, sir, should I take the first positions or last positions in the frame? It's all agreement. How these two computers agree, that's a protocol. We'll see that thing later. That means, so there will be a common agreement. First of all, we'll see what is the common agreement generally people follow in the real world. But in our hypothetical world, this frame should have an address somewhere. We take the first bits here. So your system A should send message to D like this. So this is a message and it is especially for D, address is 400. In that way, so this message will be passed to B. Now your B's NIC card should be sophisticated, then only it will happen. So there are two things. So far in point to point connections, like only two connection, like with two computers we have seen. So whatever the message comes, B was reading, correct? Now this time B should see this address and he should forward it. Such kind of improvement should be there, correct or not? So I can say that now whenever multiple computers are connected, then all the computers first of all should check the frame for the address. If that address matches with their own address, sir, my question, how these addresses will be designed? Like who will decide it? The network interface card manufacturer. Every computer will have NIC card, you know that, correct? So that NIC card is going to have a physical address. So that is fixed forever. Every computer will have a unique physical address and especially that will be 48-bit address. Okay. Now, so this physical address is going to decide whether, so every computer will have a physical address. That's why every computer knows what is the physical address of that computer. That's quite obvious, right? So now B will take that message and that means NIC card. So that B, from now onwards, whenever I say B, it means it's NIC card. So because we are in data link level, correct? So this NIC card is going to do all this stuff. So this NIC card will check that 400. Is it my own address? No, it will be forwarded, right? So that is one way. I'm not telling that this is the only way now people are using in the real world. No. So this is a way we can do now, correct? So B will send that message to, it should forward, correct? Now after that, this NIC card also should check that and it should forward it. Such a understanding if every NIC card has, then definitely it will reach here and D will read it and then it will be happy, correct? But here one problem arises. So if there is a failure in the cable somewhere, example, there is a clot here. It happens in the real world, correct? So when there is a problem with one cable, if some cable breaks, then everything will break. That means all the computers will be collapsed. That means now you can't send from A to D, correct? Now you can't send from B to D. In the worst case, if there is a break here, then BCD can communicate, but they cannot communicate with A in that way. So in graph theory, we can say, so you will form multiple connected components, correct? It's a tree structure. That's why generally no one will keep their computer. Generally, it is not preferable to have this kind of thing, right? But it works, right? But we should take care of the physical breaks, right? Now, that's why topology comes into the picture. This is one topology, tree topology, right? Now we will see various topologies one by one. One basic topology is mesh topology. So in mesh topology, what we do is, example, I have four computers, A, B, C, D, and I want to connect them. So what I do is, rather than connecting A to B, B to C, C to D, I connect every computer to another computer through the ports. So now we'll see the ports A and this is B. So A is having 3 ports, minimum ports required is 3. So one port is used for connecting to one port of B. Similarly, B will have 3 ports. Okay, now C will have 3 ports, D will have 3 ports. Okay, now here let's take here 1, 2, 3, right? A to B, then A to C like this, A to D like this. Now B2 is done, B to C, B to D, right? So B to D is like this. So lot of cables, you can understand that, right? Now C to D, now A to D, I already done, sorry, C to D, anything else? So everything is done. So here B to D, I'm sorry. Yes. In that way, so every system is connected to every system. We require minimum 3 ports in every computer. What, sir, if I want to connect 100 computers? Then your NIC card should support, correct? So there should be definitely. Now this computer will not work, right? Because it has only 3 ports. Then when you want to go for hundreds of computer in this model, then every such computer should have hundreds of ports, right? At least 99 ports, so that we can connect that to other 99 computers. Let's say we have so many ports, we specially designed our computers so that there are a lot of ports, then we can connect it. What's the advantage? If we lose one communication, otherwise if one line breaks, still A can send message to B and that B can pass that to C, correct? And because this C is going to be A to D connection, I think. Okay, see here, like it is going to C. So then if that communication is gone, then still A will be able to send it to B and B will send it to C. In that way, so we can always have, I can say, reliability. That means this system is robust, and if you lose a lot of connections, still through some other part of the communication path we can send the messages, right? So this is one thing, advantage, reliable and robust. Second one, the disadvantage is lot of connections. See, everything is messed up. Example, let's say in your house, try to connect 100 computers in this way. So you will be completely filled with cables, and even once you go inside the room, then you can't go out, right? So you will be messed up. Second thing, so every NIC card with multiple ports, each port, this is a hardware design, right? So when you have lot of ports, definitely it will be costly, right? So lot of ports will increase the cost of the design and our hardware, so that this is a costly affair, I can say. We require lot of cables. See, this cable we should purchase, right? So if imagine, let's say the computers are distributed all over the city and you want to have mesh topology, then how many cables we require, right? We know that it's a complete graph. How many cables we require, we will see. How many, rather than cable, we say connection or link, because this link may be sometimes may not be cable, right? It may be some radio signal. That means you may send a signal from A to B through another media which is not cable, maybe something like radio frequency, right? So that's why, maybe radio signals, that's why. So we say link, doesn't matter for us whether it is a physical cable or not, link. So how many links are required in this mesh topology? So the number of links, if you see, between every two computers there is one link, correct? Then it is a complete graph. whoever studied graph theory, they will understand that number of edges in each edge is nothing but one link. Number of edges in a complete graph is n into n minus 1 by 2, where n is nothing but number of computers or nodes. From now onwards, I might say node, otherwise computer, all are same. So everything is a computing device, so which is going to send or receive the message, right? So n into n minus 1 by 2, where n is nothing but number of nodes. It's a costly affair, right? Now we will go to the second one, which is nothing but star topology. Sir, who will use this kind of mesh topology then? Let's say, so there is a military system. That means in military you require some computers which are very important. Let's say there are some 100 military computers of India, and they should be well connected. That means if one cable breaks, otherwise one link breaks, they should not be able to communicate, right? Still they should be able to communicate. In such cases we use mesh topology, right? Where reliability and robustness is very important. But for general case, like example, it is my small company startup, otherwise let's say in house, otherwise in a college there are hundreds of computers, don't use mesh topology because it's a costly affair, right? Second thing, star topology. In star topology, what we do is generally, so we connect all the computers to one central computer. Example, let's say I have 4 computers A, B, C, D, and I connect them to a central device. Usually it is hub, otherwise switch. So we talk about switch later. At this moment, let's say it is hub. So what hub is going to do, we will see. Hub is a device, so it will have lot of ports. In this problem we require, because 4 computers, right? We have to purchase a hub which has 4 ports. Okay, now we need only 1 port for 1 computer here to connect in this model. So A is this port will be connected to one of the port of hub. B is this port will be connected like this, like this, like this. Now, so whenever you have hub, generally what hub will do is, whatever the message comes to that hub, it will relay it. This is called relaying. We know what is relay, right? Simply, whenever relaying means when some message comes, then give to everyone. That is relaying. So your hub generally is a relaying device. So when A sends a message, that hub will such a way it will have. Don't ask me, sir, how it happens. So why it happens? Because it will have, hub will have some software and hardware. Because of that, whenever such a way it is designed. So I'm just telling the functionality of hub. The functionality is, whenever generally a computer which is connected to that hub sends a message or frame, that frame will be relayed to other computers. Let's say if it happens. Now we already know that we are not simply just sending the frame, correct? So we are sending the frame, correct? With on that there will be, this entire thing is frame actually. So in this frame we will be having address also, right? So address. Now when you send such frame, then what happens? Example, A sends it, then hub will see it, and simply it won't see actually. That means it won't examine the address, everything. Directly that will be relayed. Now B will get it, C will get it, D will get it. Sir, it is not intended for B, right? Then if B takes it and if it reads it, then what happens? Yeah, it happens. That means what happens means, so B will be able to read everything. If it is a secret message which you want to send to D, B will read if really B wants. But these are all your computers. You connect your computers only when you don't want to worry about security. Understand? So here whenever I connect my computers like this, then each machine is capable of processing your frame. But generally they don't do, right? Such a way we design our software, right? So usually our protocol will work like this. A will send the data to hub, hub will relay it. Every other computer will just see the physical address. If that physical address matches with their own address, then they will take it and they say it's mine. Otherwise, so it will simply discard the packet. Why, sir? Why don't it resend? What's the purpose? Because this hub is going to send it to everyone, right? So it's like a broadcast message, but there is a difference between broadcast and this one. Here finally this message will be read by only D. If this address is D, so only D is going to read it. Now there is another way we can send the message, that is broadcast message. Now there are 2 kinds of messages, like there are 3 kinds of course, but let's focus on 2 kinds first. One is broadcast. Okay, what is broadcast? And there is one more thing, multicast. So we don't worry about multicast at this moment. I will just define what is broadcast, multicast, everything. So usually broadcast message is nothing but it is for everyone. Okay, multicast, single cast means only it is for exactly one person. Now multicast means for a particular group. Maybe we fix the groups. So whoever wants to use multicast system, multicast message system. So there will be a group, like example your WhatsApp group. So you will have various groups, right? Otherwise your Facebook groups. So there will be a option of multicasting. You can send one message to some particular group of people, isn't it? That is multicasting. Similarly, in this communication system also, we can implement broadcast messages, multicast messages and single messages. So in single cast message, so whenever, otherwise personal message I can say, we only write the destination address. Okay. Now if you want broadcast message, then there will be, I will tell you that bit pattern. Simply in the field of address, we should write a, a particular, a fixed binary pattern. That is not a valid address of any computer. So we will see what is the exact physical address for broadcast message. Example, at this moment, just believe that it is all ones. In the address field, if you write all the ones, then your hub will, of course, hub will relay it. Then B, C, D will examine that address and they think that it's a broadcast message because the pattern matches what. Who will do all these things? Network interface card of your computer. So, sir, but what if my NIC card doesn't know that? That means this is not a common agreement. So there is no common agreement, then communication system will not work. Computer networks will not work. That's why remember one thing. So here in this model, whatever I am telling, so in this one, everyone should agree first of all. Such a way there should be a software. Okay. So we will see, sir, generally a computer will have what kind of software we will see. It depends on your network. Now let's focus on this network and don't worry about all that things at this moment. Only focus on this thing. We are just introducing all the, different kinds of topologies. Now focus on this topology first of all. So in this topology, then you are able to send broadcast addresses if you want, multicast messages and single messages, correct? Now this hub is very important here, correct? If this hub gets corrupted, otherwise hub gets damaged, then everything will be collapsed. That's the only problem with this model. Otherwise, happily anyone can send message to anyone. Example, A wants to send a message to D, simply creates a frame, A creates a frame, correct? So with physical address D, and that's it. It will send it to hub, hub will relay it, D will take it. Understand? Now here one more thing we should discuss, that is, so one thing is, one negative thing is hub collapses, then everything will collapse. Second thing, so collision, that means example A is sending a message, okay, to hub. At the same time, so C also want to send a message to A. Just see, A wants to send a message to C, C wants to send a message to A, correct? Then at a time simultaneously it happens, what happens is, now see, C's message is coming to hub, hub will relay it, correct, on this cable. Now at the same time A also want to talk to hub, that means A also wants to send some message to C on same cable. You are understanding? So clearly I will show here, this is your hub, okay. So this is one port and it is through that, let's say A is connected. Now through another port, let's say C is connected. Now at 9 o'clock, I will tell this with time. 9 o'clock, what happened? C just sent a message to A. It reached, now slowly through this cable, that message reached here to hub. Immediately hub will relay. So the time at relaying time is 9 o'clock 5 minutes. Now at 9 o'clock 5 minutes, now this message whatever sent by C is at, I can say, now this point. Otherwise at hub. Message it at hub. Now that message will be immediately relayed, correct? It will be taken by your hub and through this port it will send. Not only to A, it will send to B, it will send to D, correct? But at the same 9 o'clock 5 minutes, what if A also starts sending message to someone, like say B or C, whatever. Okay, now at 9 o'clock 5 minutes, A sends message. Now see, there are two messages in the line, correct? Now see, at 9 o'clock 5 minutes some message is coming to A. Why? Because it is because of C relayed some message, correct? C relayed a message. Now at the same time A is also sending a message to hub. Yes, it can happen. Then signals will be garbled, correct? Assume that let's say this channel is capable of only sending one directional data, right? So generally people will have half duplex links most of the times. Maybe you might have full duplex. If it's a full duplex, there will not be any problem. But if it is half duplex, that means your cable is capable of sending a message from A to B. That means in this cable, so either A can send it to hub, otherwise hub can send to A. In that scenario, what hub and A wants to send at a time? Sir, why they want to do that? They don't know that A doesn't know that hub is going to send and hub doesn't know that A is going to send. Then definitely something happens, that is nothing but message garbling, also known as collision. So we have to resolve collision when we have this kind of star topology. Now in bus topology you will have a common cable. So this common cable, and this is let's say copper part. This is your copper. So this I can say shield. This shield is going to protect this copper. Now every computer, whenever it wants to connect through this medium, so it has to tap, otherwise it has to go into inside and it should connect to this copper wire. So similarly this another computer which wants to connect to this medium, so it should go into this, finally it should break this cable and it should go inside, piercing we say. Now in that way another computer also will pierce into this cable and it will reach this core. So we can say it is core. Core is nothing but copper, real copper. This is plastic. Now so because of this point, this is called actually tapping. Okay, so here there is a tap, there is a tap. So whenever there are multiple taps, what happens is your signal will be weakened, because here because of this point another cable is touching here, right? Because of that what happens, your signal strength will be reduced. So when you have multiple taps, then what happens? So initially your signal is like this, slowly it will become like this, like this, like this, in that way. So it will be weakened. Then what we have to do is we have to maintain frequent repeaters. That means after some time, if you have very long system like this, that means if you want to maintain hundreds of computers, then we should keep repeater in between them. That means keep a repeater here. When you connect repeater, that repeater is going to strengthen the signal. That means it is going to create original signal again. Then that will be again repeated. Understand? So that is one thing you should understand. So that again we can connect multiple computers. So this tapping is one of the limitation. We can't have lot of taps. Second thing, so how this system, that means how this communication medium will be used. Same, already we have seen star topology, right? So let's have one computer here, another computer here. In this model what happens is, so one computer, let's say this is A, B, C, D, E. Example, A wants to send a message, then that A is going to send message to this cable. Okay, so whenever message comes here, then automatically it will go this direction and this direction. So the message which went through this direction, it will be kindly absorbed. But the message which comes this side, so remember one thing, example, message means what? Signal, right? 1. So when you send a bit 1 through the signal, that 1 comes like this, 1, and same 1 goes like this also, like water. When you send water into some pipe, it will go this side, this side. But if this side, if you see, it will be water, the right side also it will be water, but the quantity will be less, correct? But in signals, when you send a signal, same signal will be transferred to left side, right side. That's why now message definitely comes here, right? That will be sensed by D, so that will go through D. Then similarly it will come to E, it will come to B, it will come to C. Though everyone will see that. But the thing is, if you want to send only to E, then we will be writing physical address of E on this frame, correct? So we write physical address here and we send. Now one important question you might have, that is, sir, how A knows E? We will see that later. How A, B, C, D, E knows others' addresses so that they can communicate, correct? That is one question we are going to answer later. At this moment just we are understanding physical topologies, only focus on that. So in this is called bus topology. In this bus topology there is only one common medium. right? So this is not point to point connection. There is no point to point connection between the computers, correct? So here to here, A to D, there is a point to point connection. No, between no two systems there is a point to point connection. It's a different model. This is called multi point connection. Multi point. So that means your connections can be multi point, otherwise point to point. We have seen point to point. I can show like this. This is your point to point connection. Then this is a multi point connection where multiple computers are going to share the medium. But in point to point connection, so the medium is shared by only two computers. Understand? Now here the only thing is, sir, when there are multiple computers, what if everyone wants to send a message at a time? Otherwise A comma D wants to send a message at a time, what happens? Same problem like this star topology. Example, A wants to send a message, okay, at 9 o'clock. So it reached here at 9 o'clock. D also wants to send a message at 9 o'clock, it reaches here. So whenever message comes here, it will go this direction, and the message which is sent by A also will come to this direction, then it will collide, correct? There is a collision, then A cannot send a proper message to D and D cannot send a proper message to A. It's quite obvious. So they are sharing the resource, which is cable. Only one can send, right? Maybe it is half duplex or anything. If it is full duplex also, if A, B, C, D, everyone want to send the message to each other, so definitely there will be collision. You can easily understand that. But how this collision will be resolved, we will see. Okay. So whenever you have bus topology, generally we have to address collision. So how to detect the collision and how to avoid it, we will see. Next, the next topology is ring topology. So before going to ring topology, then I would like to tell one thing. What is the advantage of this model? Though there is a collision, why we need it? And star topology also. We can happily use mesh topology, right? Then why are you going for other topologies? In mesh topology, there are a lot of connections. It's little bit, costly. That's why we came to star topology and bus topology. So we will see bus topology. In this one, connections are very less. See, so you require one cable here, 1, 2, 3, 4. Every computer needs only one cable, and especially that cables are only connected to that common medium. Correct? Now this cable. So we have very less number of connections here, correct? And we are sharing the medium. So obviously it will be cheap, right? So I can say this is very cheaper. Similarly, when it comes to star topology, that is also cheaper. Now we'll see what is, how to compute the number of links in star topology. Here there is no link model because this is only shared medium. That means all the computers are sharing one cable, correct? But in point to point connections, whenever there is a point to point connection like this, then only we talk about a link. Then only it will form a link, correct? So if the question is about number of links, then we have to discuss only in mesh topology and star topology, correct? So we will see the number of links in star topology, we have forgotten. So this is your hub, okay? Now let's say you are connecting 4 computers A, B, C, D. Then how many links are required? We link like this, A to B, A to hub, and B to hub, C to hub, D to hub. 1, 2, 3, 4, right? So I can say that if there are n computers, only n links. But whereas in mesh topology, it was n into n minus 1 by 2 links. Now the third one, bus. In that bus, so we are not we can't measure the number of links. There is no link. That means no two computers are directly connected, right? But if you want to know the cables, so here one cable, 1, 2, 3, every computer is connected through one cable. So again n cables, right? If there are n computers. So this one and star topology are cheaper than mesh topology. But the problem with bus topology is if this medium is corrupted, let's say, otherwise, let's say there is a break on this cable, then everything will be collapsed. Now systems cannot be operated. Only, sir, still we can do one thing. What? A can send message to D, right? See, A can send message to D. Yes, A can send message to B. But A cannot send message to C. And one more thing problem, even A cannot send message to B properly. I will tell you the reason. So why A cannot send message to B is in this one. See here, A, B, right? This is a cable, right? Now, whenever A sends message, it will come like this. Since there is a break, it will come back. And that's why that whatever comes, it's like a backwater. Like imagine it like a water. Then whenever water is going like this, then it is coming back. Then the water which is coming back, it will again hit that message and message will be garbled. So some noise will be created. That's why whenever there is a break in the link, which is common link in this bus, so definitely your systems will be collapsed. That means we can't communicate. Collapsing here means your medium will be collapsed so that you can't send message to anyone to, I mean no one to anyone. Understand? So the last one is, that's why we should be careful with bus topology. That's why the better thing is star topology. If you compare with bus topology, star topology is better, because star topology is also having very less number of cables, right? Only n connections. So what is the advantage of star topology over bus topology, sir? See here. In star topology, if same thing happens, let's say this is your hub. 1, 2, 3, 4. Like this, right? They are connected like this. A, B, C, D. If hub is gone, everything is gone. We know that. Okay. Apart from that, if you see the cable problems, like if this cable breaks, when it comes to cable problems, if this cable is having a problem, then still it works, correct? So still only A cannot send message to others, but B, C, D happily can communicate. That's one thing, right? So one cable breaks, then there will not be any problem for other computer communications. That is about star topology. So that is the advantage over bus topology. Otherwise, in bus topology, if I cut the cable in between that common cable, everything is gone. But here, if I cut the cable somewhere, only that communication will be gone, right? Apart from that, so but the problem with star topology is, if hub is gone, that means if there is a problem for hub, everything is gone, right? Because hub is going to redirect otherwise relay the messages. Then if you don't have hub, how can you relay that, correct? That's the problem with star. But they are cheaper than mesh topology. Now we'll see ring topology. So in ring topology, we connect our computers to a ring. That means your communication medium will look like a ring, and computers will be connected like bus topology. So that means it's a shared medium. So this is called ring. So whenever you have a topology, we should think about, in this topology, how two systems can be communicated, correct? That is the only thing we should answer. Think about it. How A can send a message to B in this one. So there are various mechanisms. One mechanism which is introduced by IBM people. So that means IBM people connected their computers in a ring topology, and they introduced some protocols for governing the communication. That means, so they introduced some protocols, because of that communication will take place in a peaceful way. That means without collisions and everything. That is called IBM token ring. So now before discussing this token ring, IBM token ring, example, let's say you don't have IBM token rings protocols with you. You have simply computers. Then how communication will take place in your model? Think about it. So we can create our own model, but the only thing we will see, why generally we should not have our own protocols. At this moment, let's say, think about, so that you get idea. That's why I am asking you to think about your own rules, so that you understand what are the problems with this ring. Example, let's say A is sending a message. Okay, assume that you have designed such a way that that ring allows only one-way communication. That means, so it is anti-clock, okay, otherwise clock. There are two directions, right? Only in one direction you are allowed to send the message. That means your message can flow in only in one direction. Such a hardware support we have. So that means it depends on your cable property. Somehow you have cable such a way that it allows only one directional data, right? Then what happens when you send data? If A sends some data to E, then it will come like this. So in this model, you think about it. I'm just trying a possibility. What we can do is, so we can send message to everyone. So whenever a message comes through this cable, it should go to H like ring topology, and it should come back. Again it should go down, and it should be again repeated. So every computer should work like a repeater. So whenever some message comes, it is not its own message, then it should send back in that way. Then this message comes here. Then when it comes here, then F should again send it back. Understand? So in that way, if we do, automatically E will receive that message. But the only problem is there is a collision. if multiple computers wants to send a message at a time, example A wants to talk to C, B also wants to talk to C, what happens? You see, A is sending a message, right? It goes like this and it will come back, right? Now C also, otherwise B also sends a message at the same time, then there will be a collision. See, then C cannot understand what is exactly, what message it is, correct? So when there is a collision, how to resolve it? IBM people resolved it in a one way, that is token ring. If you want to know, then just learn it, but it is not part of the GATE syllabus. I will just give major ideas in that protocol, right? So in the token ring protocols, one important thing what they did is they added a concept called token. So every computer somehow will acquire the token. That means token is something but a small message. Okay. Initially, when systems all started, that means when you switch on all the computers, then immediately one message will be automatically transferred. Such a way they have a mechanism. Then this token will pass like this. So someone, whenever some token reaches G, really now G has some message to send to others, this token will be captured. How to capture? Simple. So this line will be temporarily removed, so that your message will be stopped. Correct? Example, you have a cable like this, some message is flowing like this, you cut it in between temporarily, then automatically this entire message will be dropped. Correct? So in that way the token will be dropped by G, that means it will take it immediately, then again it will fit it, that means it will again reconnect it, then G will send its message. Now only G can send it. Now others never dare to send the message at this moment, because what is the rule in this token ring? Whoever has token, only that fellow should send it. That's why at a time only one person will send. In that way collision problem will be solved, isn't it? So there are some other stuff we don't require to learn because token ring is not part of the syllabus. Okay, just we were learning topologies, how to connect the computers in so many different ways. We are just learning. It's introduction, that's it. But we don't worry about, at this moment you don't bother about when you connect your computers in a ring model, how communication takes place, how collision should be resolved. Everything is not important at this moment, because one of the ways is token ring, that is not part of the syllabus. So that is a one favorite protocol, I can say important protocol. But at this moment when you are learning all these topologies, just understand what's the structure of it. Physical topology we are learning, but how communication takes place, everything is not important at this moment for you, and whenever it is really required I will teach it. Understand?